Hi, this is Mick Elliott from Electronics Specifier. I'm with Mark Dickson, Chief Marketing Officer of Panthronics, which is a startup in the NFC area. Mark, can you give us some background on Panthronics, how it started and what its ambitions are?
Yeah, sure. So we've been around since 2014. We were actually grounded in Graz, which is actually a hub of semiconductors and NFC. It was actually started by two industry experts. They understood the NFC market. They saw the way the NFC market was going, in particular how NFC was being forced into form factors that were getting much smaller, where you had to have performance behind things like displays, so think about mobile phones. And they realised that the existing architectures were not going to be fit for purpose in 3 or 4 years' time. So what they did was they pulled together some experts in the area, of which there were plenty in Graz, and said, guys, grounds up, develop something that's going to meet the market needs further on the line. So something that's much more robust when working with a display, something that can get much more output power and have much more sensitivity. And that's when they came up with the sine wave driver and the split stack architecture. So as opposed to the concurrent products on the market that had a square wave driver or push-pull driver, and what we do is we deliver a sine wave directly from the chip, meaning we can directly connect to the antenna. That's our DRAC technology, which means that we have a sensitivity an order of magnitude better than competition, and we can produce much more output power onto the antenna, which is ideal for customers. They have much more margin in their designs. Yeah, they can reduce the costs because we don't have external filtering. Yeah. Okay. And so that's basically the background. We were started off life as an IP company. But they actually had customers that were saying, listen, this technology is fantastic, we want it. So what the founders did, they decided to change the strategy a little bit. They went for Series A funding, and then that's when we joined. Yeah, so we come from companies such as NXP and ST. When I say we, I mean marketing, sales, applications, all the revenue driving operations basically. What we saw was, we said that the technology itself is ideal for IoT and mobile, but there's a new market coming, which is NFC charging. And that's where we saw our architecture was perfect fit for this. Yeah, and that's when we started to address the products that you'll see today, which is on NFC charging.
Okay, and do you make those products yourselves, or is it are they made for you?
Yeah, so we design them, all the development, all the specifications, everything's done by us. But of course we outsource the wafer fab as TSMC Global Foundries, and we have the OSAT ATX that does the packaging and final test. We have all our supply chain management in-house. That was very important. So as we're scaling up into a full product company, it was extremely important for us to have all that in-house. So our QA is in-house, our test development is in-house, our product engineering is all in-house as well. So that means that we can turn around any issues very quickly, and we can also qualify the products very quickly ourselves.
And customer technical support's in-house, I guess.
It's customer technical support's in-house as well. Yeah, so we've got we have a service desk, and we have a dedicated lab for the customers. In addition, we have technical support in-house in America and in China.
And do you work through distributors as well, or?
Yeah, we do. So the channel is very important to us. So we've set up a global distribution network. We have a couple of partners that we use. In addition, we use a rep model, particularly in America. So we've got full coverage on North America with reps. They're very, very important to us. We treat them just like our own sales. Yeah. Sure. And in China we have several distributors. We also have dedicated sales as well, and then we have representation in Korea and in Japan.
So pretty much truly global.
Yeah, exactly. It's yeah.
Right, just moving on to the products, and before we get into, I know you've got a new product here at the show, but it's fascinating there with your gum shield product, which you helped bring to market. So can you just talk us through that a bit?
Yeah, definitely. So Prevent Biometrics. So what they do is they've developed a gum shield basically that can that's there to monitor for contact sports. Yeah, so it can monitor the amount of impacts that a sports person would have during a game, or if they're boxing. Yeah. But they have some issues with this because it has to have a battery in there, and if you can imagine having a connector, it would be quite bulky, wouldn't be too comfortable.
Yeah, sure.
Yeah, and it also has to be hermetically sealed, so contact doesn't really work. You have existing wireless charging standards out there, such as Qi. However, it doesn't really fit here because of the size. It's very, very difficult to get a Qi antenna on there at the cost and the size that you would need. In addition,
and I guess the shape doesn't help much.
Exactly, Mick. Yeah. But as you can see here, when they put it in place, there is some displacement there. And with Qi, if you displace this at all, then the efficiency drops through the floor. Sorry. And that's where NFC actually is perfect, because NFC allows for much smaller antennas, much lower cost antennas, a much more compact design, and in addition, it also allows for some spatial displacement and still yet will charge a battery.
And that's out on the market now, is it?
This one's out in the market. They've just won. This is public information. They just I think a couple of months ago they won the contract with Pro Rugby in Europe. Oh, okay. Actually, so these are out there in the market. Yeah, and when you talk about biometrics, another interesting application that you'll see out there that's ideal for NFC charging is the biometric and smart ring. Yeah, this is also something that we see a lot of traction with. Yeah.
Well, so a smart ring for.
Oh, smart rings. So I mean, you can actually see them out there. I mean, if you have a look at the NBA, if you watch the NBA, actually there's a Finnish company called Aura, and you can see their advertising all over the place. And basically, it's about the user putting the ring on and measuring the biometrics. Yeah, as you would do like a fitness band.
Yeah, sure.
Yeah. Okay. Yeah, and this basically, you take it off at night and you put it on your stand. Yeah, but you don't want to have it connected. You don't want a connector on this, and also you want to be able to move it around. And plus, if you've got different sizes of rings, different fingers, you're going to have some movement there, and that's where NFC comes into play. Yeah.
Right, just moving on now. New product at the show.
Yeah. So I mean, so basically, this NFC charging, it's. So basically, NFC is an established technology. Yeah, you see it's in the mobile phones, and Qi is also it's very broadly adopted as a wireless charging standard. However, what's not done before was NFC into wireless charging. So it's an existing technology into a new application space, which means that there's a lot of challenges there as it's being adopted, and there's a lot of barriers to adoption as well. Some of the barriers to adoption that the users or consumers have seen is primarily is the limitations on the RX side. So that's on this side, on the RX side, yeah. And it's primarily around getting the size down to something that can be integrated, getting the cost and complexity down to something to be integrated, and getting the efficiency high enough so that it makes sense. Now we're talking about batteries that are typically 250 milliamp hours and below. Yeah. And if you looked at all these different types of solutions that were being pushed out there, the RX side of the equation meant that it was almost impossible to implement NFC charging. Yeah. In addition, having a full system proven out end to end is something that's extremely important for the consumer or the customer to design in, because it's such a new and emerging application for NFC. Now, so what we did is we already had the Polar, and that was with our DDAC technology, sine wave driver, which we talked about before. But what we didn't have was something on the receive side of things. What we did is we had a discrete implementation, as all our competitors do as well, which is good enough for some applications, but didn't really open up all these doors to get the full potential of the NFC market. So what we did, we have basically taken all these discrete components here. That you can see, this is the discrete components that you would find on a typical receiver, and it's, as you can see, it's quite a lot of space there. Can you imagine putting this onto a smart ring or a stylus or some smart glasses? Very difficult. And what we've done is we've developed a product that basically incorporates everything onto here, onto that one piece of silicon.
Right. Okay.
Yeah. And that includes the rectifier, that includes the battery charger, It can be in standalone mode, so you don't even need an MCU. And this basically reduces the BOM complexity, the BOM size, the BOM cost, the efficiency. There's much less components on there for tolerance issues.
Okay.
And then what we did is we're working together with our reader.
Yep. Okay.
We now have a complete end-to-end solution. So what we do is we have an SDK for both. We have an SDK that's fully proven out over a number of different parameters that we can give away to our customers. And this really helps to accelerate the design in time and make the whole design much less challenging for them. And in addition, opening up all these different applications.
So what applications does it open up? What sort of customers are we looking at?
Yeah, so we're looking at smart ring. Yeah, we're looking at smart glasses. Now you will see some out there that are already implementing NFC, but it's not broadly adopted. What we're talking about is, really allowing for broad adoption of these type of applications. Yeah, as I said, smart ring, smart glasses. We have biometrics, medical, hearables.
Okay.
Yeah, this is the big one.
Yeah.
TWS. Yeah, these are going to be the big applications that it's going to be opening up. So any small, battery consumer device with that's 250 milliamp hours and below. Yeah.
And it's available now?
So it's available for, we've got alpha samples at the moment. We're sampling to lead customers. Yeah. The issue we have now is we're having to say no, because we have the traction that we have with this product is unbelievable. It's very, very rare that you actually see traction like this in the industry. It's phenomenal. Yeah.
Mark Dickson, thank you very much.
That's all, mate.